Okay, hope you had a great week, and I'm pre-recording this, so I'm recording before Easter, and Easter would have already taken place when you view the video, and I trust you had a great Easter. You know, nothing more important than knowing for sure that you're born again. First John says, and this is the record that God hath given to us eternal life, and this life is in his Son. He that hath the Son hath life. So the question is, do you have the Son? Not do you know about the Son? Do you have the Son? He that hath the Son hath life, and he that hath not the Son of God hath not life. The question is, do you have Jesus Christ? How do you get him? You have to receive him. You have to receive him. You have to understand the gospel, understand you're a sinner, and that Jesus Christ died on the cross to pay for your sin, that he rose again, and therefore then you must receive him. Repent of your sin and ask him to be your Savior. Receive the gift of eternal life. I know most of you understand this, but I just want to be sure in these days that we're living in that each and every one of you have trusted Jesus Christ as your Savior. I did that June 29th, 1980. So glad, the best decision I ever made in my life. And I trust you'll do that. The rest of that verse says, he that hath the Son hath life. He that hath not the Son of God hath not life. These things have I written unto you that believe on the name of the Son of God, that you may know that you have eternal life. I trust you know that. All right, let's get into the review here. Beginning of the chapter, really key foundational stuff. Pretty soon we're going to get into the more intricate aspects of trigonometry. And so you would have learned the things that we've done so far in geometry, and then we're going to go so much further. So let's see what kind of foundation you have laid. All right. Questions 1 and 2 says state the 3 basic trig ratios for each acute angle. Okay, so we're going to think sine, cosine, and tangent. I'm going to first off deal with angle A, right? So the sine of A is the opposite, which is the 2 over the hypotenuse. We don't have that yet, so we got to figure out the hypotenuse using the Pythagorean theorem. All right, so we all know that a squared plus b squared equals c squared, and so c is the hypotenuse, so the hypotenuse is the square root of the sum of the other two sides. So 6 squared is 36, 2 squared is 4, so on this one we end up with the square root of 40. We can simplify that. That's a 4 times 10, square root of 4 is 2, so 2 times the square root of 10 is what we have here for the hypotenuse. So that goes underneath, 2 times the square root of 10, and of course we got to do some simplifying, right? And we learned how to simplify radicals. We learned how to rationalize the denominator. We got to go square root of 10 over square root of 10, and that's why this thing ends up being the square root of 10 over 10. So the sine of A, the square root of 10 over 10. The cosine of A is the adjacent, the 6, over the hypotenuse, 2 times the square root of 10. And again, you see how we're going to have to rationalize the denominator? All right, well, once you understand how to do it, this is going to end up with 3 times the square root of 10 over 10. So again, we would rationalize the denominator, square root of 10 over square root of 10, and that's how we end up there. All right, the tangent of A is the opposite 2 over the adjacent, 6, brain is one step ahead, and that would be 1/3. So you get the sine, the cosine, and the tangent of angle A. Well, now we need to do the sine, cosine, and tangent of angle B. And I want you to pay attention to this. Watch what happens here. When we go to angle B, the sine of B is the opposite 6 over the hypotenuse. Do you see how the sine of B is the same as the cosine of A? That's a key concept. These are complementary angles. This is always the case. Also looking at B, so let me erase what I have here. So looking at B, now when I do the cosine of B, cosine is the adjacent over the hypotenuse, and notice the cosine of B is the same as the sine of A. All right, now the tangent of B, there's no way around that because the tangent is the opposite 6 over the adjacent. So tangent of B is opposite 6 over adjacent 2, and it's 3. It's actually the reciprocal of the tangent, right? And there you have it. All right, so that's number 1. All right, number 2, we need now, we know the hypotenuse, but we need one of the other sides. So that's going to be the square root of the hypotenuse squared, 144, minus the other side squared. Now be careful, that's minus, because you're solving for a side, right? Take the Pythagorean theorem, move the b squared to the other side, add a negative b squared, take the square root of both sides. All right, so what do we get here? We get the square root of what, 135? And does that simplify? All right, so I'm going to take 135 and I'm going to divide by 5. And that's 5 times 27. Yes, see, is a 5 times 27. 27 is a 3 times 9. So see how I'm going to get that 3 out? So this is going to be 3 times the square root. So I took care of that, of 15. 3 times the square root of 15. Okay, well that's that side. Now let's go through and work our way through all of the functions. All right, so I'm going to start off with angle D. So I'm going to do the sine of D is the opposite 3 over the hypotenuse 12, and that is of course a 1/4. Let's do the cosine of D is the adjacent 3 times the square root of 15 over the hypotenuse 12. The 3 and the 12 reduce, and we get the square root of 15 over 4 for the cosine of D. All right, and then tangent of D is the opposite, the 3, over the adjacent 3 times the square root of 15. And again, we're going to have to rationalize the denominator, right? Multiply the bottom by the square root of 15, whatever we do to the bottom. Do the same thing to the top. And we end up with what? The square root of 15 over 15. Okay, now notice again, when I go to F, the sine of F makes the 12 the opposite. I'm sorry, that's the hypotenuse, right? Be careful. I shouldn't even be at F. No wonder, see, catch your mistakes, right? E is the other acute angle. All right, when I do the sine, the opposite is 3 times the square root of 15 over the hypotenuse of 12. And so again, the sine of E equals the cosine of its complement, or D. And we know that the sine of D is going to be the cosine of E. So the cosine of E is 1/4. The sine of E is square root of 15 over 4. And I also know that the tangent of E is going to be the flip of this, right? Or I can just go to E and say opposite 3 times the square root of 15 over the adjacent 3, and that would be just the square root of 15. Okay, there you have it. So we have the 3 basic trig functions for all 3. Now I know a lot of work there, but look, you got to get this down, and you got to be able to do this. It's really foundational. All right, state the 6 trig ratios for each acute angle. All right, so now we have the 6 trig ratios for each acute angle, and now we need to work off of what they give us. So notice in number 3, all they give us is an angle. Okay, so watch what we're going to do here. So we're going to go sine of 43 degrees, and we're just going to punch this in our calculator. So 43 sine, and that is 0.6820, and we usually round to 4 decimal places, right? Okay, cosine of 43. Again, I'm just punching this into my calculator. 43 cosine is 0.7314 is the round off. Tangent of 43, punching this into my calculator, and I'm getting 0.9325. 0.9325. Now, when you get, says the 6, so we have 6 trig ratios here, so we got to be careful. Okay, so now let's do the cosecant of 43, and you have to remember this is 1 over the sine of 43. So it's basically the reciprocal of this number. So again, I just do the sine of 43 and then hit my reciprocal button. 1.46628. 1.4663. 1.4663 is the proper round off there. All right, the secant of 43 is 1 over the cosine of 43. So cosine of 43, and then my reciprocal button, 1.3673. And then the cotangent of 43 is 1 over the tangent of 43. So tangent of 43, reciprocal button, 1.0724. 1.0724. Now, getting the other angle. There's two things here. M and K add up to 90. So if M is 43, K has to be what, 47 degrees? Has to be, right? They have to add up to 90. 3 angles of a triangle equal 180. Also, I know that the cosine equals the sine. So the sine of K is 0.743 and the cosine of K is 0.6820. I know that, let's see, the tangent of K goes with the cotangent. I know that this is the way it goes, that the secant of K goes with the cosecant of its complement. The cosecant of K goes with the secant of its complement, and the cotangent of K. See how I did those last ones? I did all the reciprocals just knowing that the sine goes with the cosine goes with the sine, etc., etc., and I just use the reciprocals. Okay. Again, we're trying to build your understanding here, and so I hope that this is helping you as you work your way through. All right, next one. All right, Pythagorean theorem here, and so this is going to be the square root of the hypotenuse squared minus the other side squared. 81 minus 25. Don't trust my head on that one for some reason. Square root of 56. 7 times 8. And 8 2 times 4. So 2 times the square root of 14. 2 times the square root of 14 is what that thing is. Yeah. So, okay. All right. And now we're just going to work our way through again. So sine, and let's do R first. I'm going to save some time. Cosine R, tangent R, cosecant R, secant R, cotangent R. Okay, sine of R is the opposite, right? To always know what angle you're going from over the hypotenuse 9. Okay, that's it. That one's done. There's no reducing. Right, so let me just check, make sure we're in good shape here. Oh, the book. What did the book do here? Okay, the book also took it to a decimal. So if you did fine, I'm just going to leave them as exact. You can figure out their decimal equivalents. That's what the book did. And it doesn't say anywhere to take it to a decimal round off. I'm just going to leave it exact. Okay, no problem. All right, cosine R is the adjacent 5 over the hypotenuse 9. Tangent R is the opposite, 2 times the square root of 14 over the adjacent 5. All right. Cosecant. All right, now think. I'm going to help you out here. It's the hypotenuse over the opposite. So the hypotenuse is 9, and the opposite is 2 times the square root of 14. This one we're going to have to rationalize. Square root of 14 over square root of 14. And so we end up with 9 times the square root of 14 over 2 times 14, or 28. And again, you can get a decimal round off. All right, secant, again, hypotenuse over adjacent, right? So the hypotenuse is 9, and the adjacent is 5. That one's straightforward. Cotangent is the reciprocal. Instead of opposite over adjacent, adjacent over opposite. So of R, the adjacent is 5, and the opposite is 2 times the square root of 14. Got to rationalize again. Square root of 14 over square root of 14. I got to squeeze this one in. And what do we end up with? 5 times the square root of 14. Can I write over my little recording here? And 2 times 18. No, I can't. See, it tried to move it. 28. Okay, that works. We moved it a little. Who cares? Sounds good. Okay, and how do I do the other angle? So again, just pay attention. The cosine and the sine are complements. So this is going to be the sine of Q. Again, cosine and sine, so I have the sine, so this will be the cosine of Q. Tangent and cotangent is the cotangent of Q. Cosecant and secant, so this is the secant of Q. Secant and cosecant, this is the cosecant of Q. See how we're doing these? Look, this is the understanding they want you to have. They didn't want you to go through and figure out all the ratios again. They want you to understand the relationships, cotangent and tangent of Q. There you have it. And there are all 6 for each acute angle. All right, I know that probably took you longer than it did me, but it's important that you understand those concepts. Okay, state the other 5 trig ratios for each acute angle. So now in this scenario, they want you to understand that, hey, draw yourself a right triangle. You can draw it any way you want. I'm going to put theta right there, all right? And I know the sine is the opposite over the hypotenuse. Now again, I got to do the Pythagorean theorem to figure out the third side, and then I need to work off of all of that and just checking to make sure what kind of format the book is putting these answers in. Yeah, okay, so we are just simply putting them in ratio form. So this is going to be the square root of 29 squared minus, that's 841, minus 400, right? 20 squared. And that's going to be the square root of 441. 9, that's divisible by 3. 147, that should be divisible by 3. It is. And, 49 is 7 times 7. This is square root of 21. So 21 squared should be 441, and indeed it is. Okay, so there our side is 21. Okay, good. Now we're ready to work through all state the other 5 trigonometric ratios just for the angle. So we're only doing theta. So we're going to do cosine theta, tangent theta, cosecant theta, secant theta, tangent theta. Okay. Cosine is the adjacent 21 over the hypotenuse 29. Tangent, opposite over adjacent. See how you're supposed to have these memorized? Cosecant, again, it's the hypotenuse over the opposite. Hypotenuse is 29, the opposite is 20. Secant is the hypotenuse over the adjacent. Hypotenuse is 29, the adjacent is 21. And I should have said cotangent down here. And the cotangent is the adjacent over the opposite. And the adjacent is 21, and the opposite is 20. And there you have it. There are your other 5 trig ratios. All right, 6 is done the exact same way. So again, we need a triangle. And again, it doesn't matter how you draw your right triangle. I'll put theta there this time. I'm told the tangent, and I know the tangent is the opposite over the adjacent. So I'm going to make the opposite the 35, and I'm going to make the adjacent the 12. And once again, I need the third side, Pythagorean theorem. So square root of 35 squared plus 144, the 12 squared. This is 1369, and I'm going to hit my square root button. I'm thinking this one's a square root. It is. It is 37. Okay, so here we go again. And on this one, I need the sine of theta. I need the cosine of theta. It gave me the tangent. I need the cosecant of theta, secant theta, and cotangent theta. All right, sine is the opposite over the hypotenuse, 35 over 37. Cosine is the adjacent over the hypotenuse, 12 over 37. Cosecant is the hypotenuse, 37 over the opposite, 35. Secant is the hypotenuse, 37 over the adjacent, 12. And the cotangent is the adjacent, 12 over the opposite, 35. And there you have it, all the other 5 trig ratios. Solve each right triangle round lengths to the nearest tenth and angle measures to the nearest tenth. Okay, when you say solve the right triangle, that means we need all angles, we need all sides. Okay, let me do the angle first off. It's pretty easy. If this is a 16-degree angle, then its complement adds up to 90. So 90 minus 16, and again, I don't want to do that in my brain for some reason, 74 degrees. Okay, good. Measure of angle Y equals 74 degrees. That's one piece of the information. Okay, we also need the lengths. Now, this is really key. So let me go through. We already know Y to Z is 8. We'll watch how we're going to do this. So let's go ahead and find this value here, and I'm going to call it lowercase y, right? So how do I find Y? This is the way I would do it. I'm going to use the 16-degree angle that they told us. I'm going to use the opposite that they told us, and I'm going to look for the adjacent. Therefore, I'm going to use the tangent of 16 degrees equals the opposite 8 over the adjacent, the y that I'm looking for. Now I'm going to solve this equation. So I'm going to swap out the y and the tangent of 16. Basically, all I did was multiply both sides by y over 1, multiply both sides by 1 over the tangent of 16. They swap. And now I'll just punch this into my calculator. 8 divided by the tangent of 16 degrees. 8 divided by the tangent of 16 degrees. Make sure you hit equals 1.9946. 1.9946. Oops, and it said round to the nearest tenth. So 2.0. You should have the 0.0 there to show and signify you rounded to the tenth. Don't put 2. That should be 2.0. 2.0. All right, number 7. Make sure we're in good shape here. All right, what in the world just happened there? Something is off on my figuring. Did I punch something wrong? 16 tangent. What in the world? Calculator. So I looked in the book. All right, so everything's right except the final answer. I don't know how. All right, it was actually 27.899. So 27.9. Who knows? I have no clue what happened there. Okay. So now I got y. I'm going to call this little z, and this is the last value I need for this triangle. And again, I'm going to use the angle I know, the side I know, the opposite, and now what I'm looking for, the hypotenuse. So I think opposite hypotenuse, that's the sine. So now I'm going to use the sine of 16 degrees equals the opposite 8 over the hypotenuse, the z that I'm looking for. Again, I will swap the z and the sine of 16. So now it's going to be 8 divided by the sine of 16 degrees. And I got 29.0. And again, you should include the 0.0, signifying that's where you round it off. Okay, so we've solved the triangle. We have all 6 angles identified and all 6 sides identified, you could say that the right angle is right angle, but that's boring. All right, and there you have it. That is number 7. All right, number 8. 8's a little different. Now we can figure out the hypotenuse of the Pythagorean theorem. So that's the square root of the 5 squared, which is 25, and the 7 squared, which is 49. So 59, 69, that's the square root of 74. That divides by 2. And you get 37. So that's prime right there. You cannot simplify square root of 74. Okay, so now we want to find angle measures to the nearest tenth. So we have all 3 sides. We have 2 things yet to find, angle N and angle M. Now, I'm going to use a trig ratio to figure out both angles. Well, to figure out one, and then the one will give me the other. So let's do angle N. What trig ratio do I want to use? Well, I can use any of the 3, the sine, cosine, or tangent. I always like to use values that they give you. So they gave me the opposite of N. They gave me the adjacent to N. Opposite adjacent is the tangent. So I'm going to use the tangent of N equals the opposite 7 over the adjacent 5. Now, hopefully you remember, how do you get N? The measure of angle N equals tangent to the -1 of 7/5. And you just punch in that into your calculator. So tangent, however that's, the way you calculate that into your, punch that in your calculator. So 7 divided by 5, and then my inverse tangent button, I get 54.5 degrees. 54.5 degrees. And I know that M is 90 minus 54.5 degrees. So the measure of angle M has to be, what is that, 35.5 degrees, 80, yeah, 35.5 degrees. And there you have it. I think the book actually rounded this to what, 8.6, right? If you were to just punch in square root of 74 in your calculator. And there you have it. We solved that triangle. All right, I know it's a long video, but hang in there. All right, solve each special triangle, give exact values. Again, we've learned a lot so far already, and it's important that we know each aspect. Okay, to do these, you have to have in your mind the pattern. So the way I taught it, when you think of a 30, 60, 90 triangle, you have to think of, first off, an equilateral triangle, right? Is the way I taught you. That makes all 3 angles 60, but then you split it down the middle. That gives you the 30. And do you remember I told you how make each side 2? Therefore, this would be half or 1, and the Pythagorean theorem would do the square root of 4. 2 squared minus the square root of 1 squared is 1, is the square root of 3, and there you have it. And now we're ready to do it. So solve each special triangle, give exact values. Okay, this is going to be 30 degrees for angle C. And now all you got to do is put the parts in the right spot, but be careful here. We know we have a 9. Okay, so on this one is the kind where you got to be careful, because where does the 9 correspond with the example triangle that we have? Boy, it's a weird looking triangle. They did not do the triangle to scale, let me tell you that for sure. Because where they have the 60, so watch, you got to be careful here. From the 90 to the 60 is the 9. From my 90 to my 60 is the 1. So therefore, everything is going to be simply 9 more. So the hypotenuse is going to be 9 times 2, or 18. And the adjacent here is going to be 9 times the square root of 3. And that's it. There's all the values there on that. And let me see what the book did. Your book did these kind of goofy. Yeah, see, your book, your book treated this like it was the 30. All right, I don't know what your answers in the back are. I'm looking at my answers in the answer key, and it's not right. It is not right. So, yeah, okay. Yeah, because even my book says the measure of angle A equals 30. All right, I'm going to pause the video and go look at your book. All right, hold on. Okay, just ran down in the closet, grabbed the book, checked it. Okay, yeah, I'm sorry, guys. This is probably going to drive you crazy, but number 9, the answers to in the back of the book are wrong to number 9. And number 9, as I thought, see how they drew this triangle wrong? That should be 30 degrees. That should be 60. All right, so, but the way it's written wrong. So, my answers were correct for the way it's written. So, um, that hopefully I'm going to make this clear before you guys do this, and therefore tell you that the answers to 9 are wrong in the back of the book. All right, again, it's goofy because the triangle is drawn incorrectly. That's the problem. The triangle is drawn incorrectly, and that's what messes everything up. All right, we'll deal with this again in a problem down the road. All right, let me do the 45, 45, 90. So what I told you guys on this one is you have a right isosceles, right? Is the pattern. So your right angle is up here, and it's isosceles, and so 1, 1, and therefore square root of 2, right, by the Pythagorean theorem, the hypotenuse. And again, if that's 90, isosceles, the base angles of an isosceles triangle are congruent. Okay, so now exact values. Now, notice where they put the 7. So what you can do here is you can make a ratio. This is the way I like to do it. So let me show you. This is going to be lowercase x. So lowercase x corresponds to the 1. And then its hypotenuse is 7 over the hypotenuse of the pattern is square root of 2. Now I need to rationalize square root of 2 over square root of 2. And I end up with x equals 7 times the square root of 2 over 2. All right, so number 10 is 7 times the square root of 2 over 2. Now you can do the same thing for y, but y is the exact same thing, so 7 times the square root of 2 over 2, because again, the y corresponds to a 1, and again, the 7 over the square root of 2 gives you the same thing. And you also need to say that angle y, the measure of angle y, is 45 degrees. All right, 45, 45, 90. All right, let's keep going. Without using a calculator, state the exact values of the following. So again, once again, you have to know your patterns. So let me one more time do the patterns. Equilateral triangle, 60, 60, 60. Split this top 60 in half. Makes that 30. There's your 90. 2. So that half could be 1. Square root of 4 minus 1 is square root of 3. Now I got my pattern. Okay, first question, cosine of 30. 30. Cosine is the adjacent over the hypotenuse. Square root of 3 over 2. Done. Second one, tangent of 60. There's my 60. Tangent is the opposite over the adjacent. Square root of 3 over 1 is square root of 3. Excuse me, done. Secant of 30. All right, secant is the hypotenuse over the adjacent, right? So you got to know your ratios. All right, 30-degree angle. So let's go back to, let's go red. Let's just erase here, clear it up for you guys. Oh, I can't erase too much, right? It's all right. I'm going to go to orange here. My 30-degree angle, my hypotenuse is 2, and my adjacent is square root of 3. So 2 over the square root of 3. I got to rationalize that. Square root of 3 over square root of 3. Final answer for my secant is 2 times the square root of 3 over 3. See how, and by the way, whenever they say exact values, it's always going to involve 30, 60, and 45, and make sure you're using the patterns. All right, the 45-degree angle. Again, I just drew, I know it's a right isosceles. 45, 45. Square root of 1 plus square root of 1 is square root of 2. What's the sine of 45? Pick either angle. Sine is the opposite 1 over the hypotenuse, square root of 2. Rationalize your denominator. And here is the exact value, square root of 2 over 2. Now, it's important that you learn how to do the exact values for 30, 60, 90, and 45. But what's going to happen is we're going to have all these coterminal angles. So if we can do the sine of 30, we can do the sine of 120. We could do the sine of 150. We could do the sine of 210. We can do the sine of 240, of 270, of 300, of 330. You follow all these multiples of 30 and 60 and 45. We can do 45. We can do 45 and 90, 135. We can do 180 and 45, 225, etc., etc. So learn your exact values. Learn your patterns, know how to do this and how to do that. All right, last few problems here. Use a calculator to find the measures of each angle nearest minute. Degrees, minutes, seconds. Okay, so you have a calculator button. For most of you, you're going to do that. I'm going to do it the other way because my calculator doesn't have that button. So 0.4639. And tangent to the -1 button, and this tells me right now that the measure of angle A is 24.8865, etc. degrees, and I need to change that into degrees, minutes, seconds. Okay, so that's 24 degrees. Right, so it said to the nearest minute, right? So all we need is degrees and minutes. That's a little bit easier. All I need to do is take my 0.8865, and I'm just going to use my calculator. I'm going to subtract 24, so I get only the decimal part, and then I'm going to multiply times 60 minutes. Again, if you don't, you also have a button, but I'm just going to multiply times 60 minutes, and that gives me 53 minutes, 53.195, so it's going to round off to 53. All right, cosine. So cosine to the -1 of 0.3475, cosine the -1. All right, and so this says this is 69 degrees, and I get 0.66552003. Again, I'm going to subtract the 69. Now I only have the decimal part. I'm going to multiply times 60 minutes, right? And I get 39.9. So round the nearest minute, that would be 40 minutes. 69 degrees, 40 minutes. All right, sine of A. So again, same thing. 0.5281, 5281, inverse sine. And I have 31 degrees, 0.8771, etc. Right? So again, minus out my 31 and multiply times 60. And I get 52.6, so that would be 53 minutes. Cotangent, all right, so you got to be careful here. So here we have to understand that the tangent of A equals 1 over the cotangent of A. Therefore, the measure of angle A equals tangent to the -1 of 1 over, and what is the cotangent? 0.7657. So I have to do tangent to -1 of 1 over 0.7657. So 0.7657, hit my inverse, tangent to the -1, and I get 52 degrees, and I get 0.5587, etc. I'm going to subtract out my 52. I'm going to multiply times 60 minutes, and I get 33.5, so that will be 34 minutes. All right, how'd you do? I hope you did well on those. Again, understanding all 6 trig ratios and degrees minutes there. All right, Kayla wants to know how high a 15-inch piece of wood will reach on a nightstand she's building if its angle of elevation is 47. Make sure you know your directions. Round the lengths to nearest unit, angle measures to 10th. Okay. Now it's said that a 15-inch piece of wood, so this wood here has to be 15 inches, and how high how a piece of wood will reach on a nightstand. How high will it reach? That's got to be X right there, right? This from here to there. Okay, so again, I'm going to go to my angle. I'm looking for the opposite, and I know the hypotenuse. So that tells me to use the sine. Sine of 47 degrees equals the opposite, but I'm looking for X over the hypotenuse 15 inches. All right, and to solve, all I got to do is multiply both sides by 15 over 1, right? Now remember, just let me reminder, you cannot multiply the 15 times the 47 and then hit the sine button. That is not true. I usually punch this in first, the sine of 47 degrees. So I do sine of 47, it's 0.73, etc., and then I multiply that times 15. And I got 10.97. It said round to the nearest unit, so that would be 11, and our units are inches. So number 13 should be 11 inches. Okay? Is that how you did it? I hope so. 14, a plane flying at an altitude of 22,000 feet approaches Mount Kilimanjaro, whose summit is 19,330. Find the angle of depression. Okay, so I need Mount Kilimanjaro, right? And this is 19,330. You know, again, you can go like that if you want for your mountain. However, I know my plane, all right, now I'm in trouble drawing the plane. That's as good as I'm going to get, is approaching at 22,000 feet. All right, so, and now I'm going to just make a nice right triangle, right? Okay, and find the angle of depression. So you got to be careful here. That's this angle right there. So here I'm going to reverse my triangle and do it like that, right? Two ways you can do the problem. Now, I need this height. That would be the 22,000 minus the 19,330. So that's going to be what? 2,670? I better punch that in just to make sure. Pretty sure that's right. 330. Yeah, 2670. Okay, and that's feet. And I got to be given something else. Okay, here we go. Find the angle of depression the plane makes with the peak when the plane's direct distance to the peak is 4,000 feet. I have to assume that that means this. Direct distance from the plane to the peak. It's got to mean that. Okay, now let's run the problem. I'm looking for this angle. I'm given the opposite. I'm given the hypotenuse. I'm going to use the sine. The sine of alpha, you can call the angle whatever you want to, is the opposite, 2670 over the hypotenuse, 4,000. So the measure of the angle is going to be sine to the -1 of that value. And so I'm just going to punch in 2670 divided by 4,000, making sure I hit my sine the -1 button. And we are rounding to the nearest tenth of a degree. So 41.9 degrees should be the angle of depression if I interpreted the question correctly. 41.9 degrees is correct. All right. Now be careful. You may have gotten the complement. You may have found this angle right here, but that is not the angle of depression. Remember, the angle of depression is from the eyesight, right, and down. If you're going this way, from the eyesight and down is an angle of depression. Okay. Last two problems. This is a long video. Ship leaves port 75 degrees north of east and travels 300 miles. How far east and how far north is the ship from the port? Okay, this is a good problem. So we got to set up a compass here. All right, set up a compass, and we should all know that this way is east, this way is west, there's north, and there's south. Now, they said 75 degrees north of east. All right, so that's about here. We have to go north of east. Now, there's another way to say this direction. 75 degrees north of east is 15 degrees northeast. 15 degrees northeast, right here, 15 degrees. So just showing you both ways here, but the way they use it, 75 degrees north of east. And it travels 300 miles. So I know that this is 300 miles. All right, how far east and how far north is the ship from port? Okay, that's two questions. How far east is this distance right here? I'm going to call it x. So again, I know the angle. I'm looking for the opposite. I know the hypotenuse. That tells me use the sine. Sine 75 degrees equals the opposite x over the hypotenuse 300 miles. Multiply both sides by 300 miles. And it's going to be 300 miles times the sine of 75 degrees. Again, make sure you do the sine of 75 first, then multiply times the 300. And we are rounding to the nearest unit, so 290 miles. Let's make sure we're good to go there. Yep, and also how far east? So that's the one, right? 290 miles, and that's that would be 290 miles north, right, of the east. And then we got to do it the other way. Now watch this. Come back to my drawing here. Focus here again. So this amount right here is the same as this amount right here. So I'll call that y. And same angle, but now I'm looking for the adjacent. I know the hypotenuse, so I'm going to use the cosine, right? The cosine of 75 equals the opposite, my y. Actually, I did these backwards. This should have been y and that should have been x. Oh, it doesn't matter. Whatever. I hate when I see stuff like that later. All right, 300 miles. Multiply both sides by 300 miles. And again, cosine of 75. 0.25, etc., times 300 miles, and I get 78 miles. And that would be east, right? So we're going from here to there, 78 miles. We're going from there to there, 290 miles. Okay, let me clear up my drawing here. That's good enough. Oh, can't get rid of my answer, 78 miles. Okay. To answer part B, if the ship changes course from this point, travels due east for another 300 miles, all right, purple. Now we're going to go due east for another 300 miles. Find the distance that the ship is from the port and describe the ship's position relative to the port. Okay, so this is an interesting question here, and I need to find this distance. Okay, now this is tricky because you need a right triangle. We're doing right now right triangle trig. So watch. I'm going to use let me use my purple dashed. Here's my right triangle. Do you see that? That's the only way to get that hypotenuse, right? Okay, so that's going to involve a couple aspects here. What do I know to be able to, I'm going to use the Pythagorean theorem. Okay, watch. 290 is right here, right? We found that earlier. Now I know this is 78, and so this whole way is 378. So I'm going to use the Pythagorean theorem. So the hypotenuse, the C, is going to be the square root of the 290 squared plus the 378 squared. 290 squared plus 378 squared equals, and then I'm just going to hit my square root button. And we are rounding to the nearest unit, so 476 miles. Boy, I hope that's the answer in the back, and I think they want a direction as well. Hey, all right, that's correct. So if the ship changes course from this point, find the distance and describe the ship's position relative to the port. So I got one more part left of this problem. I need to figure out the angle. So to be clear, I need this angle right here, right? So I'm going to find this angle right here. And again, I'm just going to use a trig function. And I'm going to use the values that I know. I know the opposite, and I know the adjacent. So I'm going to use the tangent of this angle called theta equals the opposite, 378, over the adjacent, 290. And it's going to be tangent to the -1 of 378 divided by 290. Tangent to the -1, and I get 52.5. 52, and we're rounding. So that's going to be 53. Angle measures nearest 10th. Okay, no, 52.5. So we're rounding to the 10th. And now I got to be careful. Those two equal 90. Now, if I were using a direction, I could say 52.5 degrees northeast, but they like to do north of east. So 90 minus that. So what is that? 37.5 degrees north of east. And is that correct? That is correct. 37.5 degrees north of east. All right, I know it's a long video. Perhaps you only watched the portions of the ones that you needed help with, but this is all foundational to the chapter. And look, this is the basic trig stuff. And then we're going to get ready really to start putting trig in a Cartesian plane and start figuring out trig in a Cartesian plane. We're going to deal with radians, and we're going to deal with trigonometric equations. That's really where we're heading. And so lay a good foundation, and we'll go forward from there. All right, that's the lesson. I hope you have a great week.